All right, so we're working on another problem where we are going to divide, have a division inequality that has a negative coefficient. So what we have is they want us to solve for x when it is divided by negative 2.25. And they're saying that it is less than or equal to negative 4. And they want us to graph the solution set. So let's see what happens. So we're going to have x divided by negative 2.25. Okay, and it is less than or equal to negative 4. Okay, and so what we need to do first is ask ourselves, is our variable isolated? In this case, we see that it is not because we're dividing by negative 2.25. So I know that we're using division over here. So that tells me that I need to use PEMDAS in reverse order. So I am going to get rid of it by using the inverse operation of division, which is going to be multiplication. So I'm going to multiply both sides by the same number. Remember, if it's positive or negative, whatever it may be, you're going to also include that sign. So I'm going to multiply both sides by negative 2.25. All right, and so what we have is 2.25. This is the same thing as like having it over 1, right? So negative 2.25 divided by negative 2.25 cancels out, and we're left with x, okay? That becomes 1, right? So that's the same thing as saying like 1x. And then we have over here 4 times 2.25. Both of them are negative, but let's just first deal with the multiplication part. So 4 times 2.25 gives me 9. And I know that negative times a negative gives me a positive. So this is going to be a positive 9. Now, remember, because we divided by a negative number, multiply both sides by a negative number, we have to change the sign so that it's no longer facing the negative 4 or the 9 in this case. We have to flip it. So you're going to flip your sign. And it makes sense because remember our um, uh, expression on the right side of the inequality was a negative value. And now the expression on the right side of the quality, once we isolate the variable, is now a positive number. So we have to flip the sign because we flipped what we were doing, okay, to make sure that this statement remains true. So I'm going to draw my number line. I'll put my 0 here. I'll place my 9 here. Okay, and so we are saying that x is going to be greater than or equal to 9. So we're going to put our circle over 9. We're going to shade it in. And then all of my values greater than, remember, the more that you move to the right, the more, the larger the number gets. And the more you move to the left, the smaller the number gets, right? So any number that is going to be greater than 9 has to be to the right of 9. So let's say that x was 10. Let's just check it out and see if this is a true statement. So if x is 10, then our statement would look like this. 10 divided by negative 2.25 is going to be less than or equal to negative 4. All right, and so when we take 10 divided by 2.25, negative 2.25, so 10 divided by 2.25, and that's negative, then we get negative 4.444. It's a repeating number, so I'm just going to put a bar notation over it. And so let's see, is this a true statement? Negative 4.4 is less than or equal to negative 4. Is that true? Yes, that's true. Negative 4.4 is smaller than negative 4. So yes, this is a true statement. That means that what we've done here is correct.